All right, let's begin a little review of logarithms. I've posted a worksheet on Google Classroom that goes with this. Let me get my markers out here. Let's begin. So we're talking about logs. We just call them logs. We don't want to call them logarithms. You can if you want to. And these are curious things. What they do is they answer the question. So say I had 3 to the x power, and I have some number. Let me put that in my calculator here. And this equals 12.651 ... So the question was, if you had this problem, how could you ever find x? Well, if you were a monk in a monastery, or I believe this was around 1600s, you would literally go and check, well, let's check 3 squared is 9. And like, okay, so it's definitely more than, x is definitely more than 2. We can see that right there. We know that. And let's take a look at 3 to the third. Well, that's 27. So we know x is less than 3. And what a lot of these monks did, and a lot of other people around Europe and Asia and other continents perhaps as well, they literally went and checked. So they're like, okay, 3 to the 2.3 power. And they get something really close to that. And the answer actually is x equals 2.31. But if you were someone before calculators, you had to just slowly figure that out. And sometimes you did have problems like this that need to be solved. I can't think of many old examples. I believe it was interest when banks were calculating, how much money you owed. They would have problems like that. Ooh, ignore that. Let's move on. So now you know that the problems that logs were meant to solve. Let's look about how we can solve. So we had 3 to the x power equals 12.651 ... It's an irrational number, so we can't reduce it down any more than that. Okay, well, I can use now log. Let's call the power of the log. So I take the log here. I take the log here. And they're going to just say, so if I take the log of both sides, the log can do is the log can take the exponent and it can bring it down here. Let's show that. So if I take the log of 3 to the power of x, it's equal to x times the log of 3. I can do that, but I have to do it on the other side. Now over here, this is going to be equal to the log of 12.651. Let's just put this now, let's just now solve for x. So we divide both sides by log 3, and don't worry what log 3 is. Just know that it cancels itself out right there. And now I can put this in my calculator, and we'll discuss what this means after we get our answer. So let's check it out. Let's get our calculator out here, and I'll just put in my log key. By the way, if you're using one like me, it's right here. It's below the second key. I'll do it though here quick enough. Log of 12.651 divided by the log of 3. And we get about 2.31. About. Put a little squiggly there. So that's okay. So that's 2.31. And we can check this, of course, here. We know that 3 to the 2.31 power. Let's put that in our calculator. There it is. We get the same answer here, about. So it's not perfect, but it shows us the utility of log. Now, what is log a little more? Let's go into it, another explanation. Here, let me get another color out. Get red and purple. Here we come. All right. So, log has a few properties of it. So we have here, there's the base number here. And then we have, let me look over here, get the exact profile. Okay, and this is just the number here. We'll just call this the number. And our answer is actually going to be the exponent. And this is the exponent of the base. So what this question is, so it's answering a question. So let's take this example. When you put log on a calculator, the base is automatically going to be 10, okay? That's our 10 here is our base. And then we'll take a known number. Let's try with, 100. So here's our number here. And remember, our question, you have to write down here. Here's the question we're asking. We're asking, what power of the base is the number? That's all. We're asking a question, and let's put that in now. So what power of 10 is 100? Well, we know the answer is 2. And of course, don't trust me ever in terms of math. You always can verify what I say mathematically. And I can probably zoom in there a little bit. Let me see. Zoom in here. You can see that that is in fact 2. Okay. There we go. So that's how that works. And this is a powerful tool, by the way. I can use different bases. We're not going to do that at this point, but just to show you an example. I have log base 2, and let's take 16. Well, log base 2 of 16 is 4. And if I wanted to put this in a calculator to check it, what I'd have to do is I have to write this as log of, I believe it's log of 16 divided by log of 2, I think will get me the correct answer. Let me see if that produces. That's how I can change my base, I believe. If not, you get to ignore this part of the video. Yeah, no, that works. So how can you change the base in your calculator? You can change the base this way. You change the base to 2, and that's how it works. All right, blah, blah, blah. I get it, Mr. Chair. Let's do some problems. Okay. Well, logs actually have some cool properties, so let's try a few problems from the worksheet I shared with you. Boy, they can be so mean on some of these problems, huh? Okay. Solve for x. Yikes. Well, they have a few properties, though. Just to look through the properties of logarithms. There are 3 major properties they want me to highlight here, and I do agree with them. So take notes if you're not taking notes. I really recommend you take notes for this section. Properties of log. So, if you have log, let's use base 10. And let's say we have, let's take 1,000 here, okay? Well, this can be split up. I know 1,000 is the same thing as, it's going to be the same thing as 100. Is it add? Yeah, I add here, and addition sign goes here. Times 10. So you see here, I can break up any number into its multiples. I believe in your, you can call this property 1. Just give you another very specific example. And let's look at the next one here. Let's use red. So if we divide, though, this is called the multiplication property. Orange. Multiply property. We have the division property. Now here, so if I have, let's take it as an example here. Let's use it. If I have the log base of 8, and I'm going to take 5 to the 56, and I minus it log base 8, 7. That's the same. Well, we know that these two are, because here we were adding and was multiplied. That means in this scenario, we're going to be able to divide them. And I'll give examples of this, of course. 56 over 7. And that becomes log base 8 of 8. And you know what power of 8 is 8? Well, that's just 1. There we go. And finally, of course, the one I already showed you before was, this is the power property, and it is the most powerful one, I think. Get it? No, anyway, dumb. So if we have here, let's take the example they give. So if I have log base 10 of 100 to the 3rd power, yikes, that's a big number. but I don't need to worry about it because I took the log of it. And that means the 3 comes down here. And it's just 3 times log base 10 of 100. Well, that's actually really easy. That's just going to be 6. Because we already... Pardon me, 6. There we go. Because remember, it's... What power of 100 is 10? Well, that's 2. So it's 3 times 2, that's 6. And that's the properties of the log. Let's take a few random problems before... I know I'm running a little long here. Okay, so I want to let's take some example problems from the back, which you, of course, have all the answer keys to. Let's take a look at some of these ones here. These definitely are harder than they need to be, but they do give you good examples. All right, let's see the ones you're going to definitely see on worksheets. I'm going to give you some better ones here. All right, I will find you better problems. But this review does good well for the properties. Well, let's do one. Okay, let's go here. Let's solve here, number 1. Log base 9. And look, they put this crap in here. X squared minus 10. I know, I almost didn't do a problem. I was going to get out of it. No, okay, we'll do one. Now, how do you get rid of... Here's something they didn't show you is... I didn't show you yet. How do you get rid of a log? Great, I have a log already here. How do I cancel it out? Well, you look at the base here. That's the clue. So if this is log base 9. It sounds a little crazy. I have to take both sides to the... like this. So I'd say 9 to the log 9 power. And when I do the one side, I do the other. 9 to the 1 power. And what this does is, if you take 9 to the power of log base 9, they cancel each other out. And so you get here, you get just x squared minus 10 equals 9 to the first power, which you know is just 9. Let's add that 10 to both sides. We get an example that x squared equals 19. 19 is a prime number, so we're just going to take the square root of both sides. And we get that x is going to be equal to, we have 2 solutions, right? Plus or minus the square root of 19. That's all we can do. I'm going to post some let's take some Kuta problems, though. Let's do Kuta logarithms, and we'll take it at the algebra 2 level. So we'll make sure you get that practice. This one jumped a little bit too much. So let's try here. Let's try some examples here. So I have rewrite equation in an exponential form. Okay, we want to evaluate each one. So hopefully these help you out a little bit. I think I gave you just this worksheet is fine. I'll post it later, okay? Took too much time today. I don't want to take much longer. I will answer questions about this later. Take care, and I hope you have a very great day.